Greetings, Earthlings. Well, today we're gonna take another look at what we got to do to get this HP meter fixed. We've determined there are two bad transistors in this custom HP part. Hybrid, I don't know, I've been calling it that, whatever it's called. So, what are the options at this point? Well, option number one is to give up. Make this a parts unit. Tear it apart, throw it away, whatever. I'm not ready to choose that option. So option two is to find another one of these parts. And there's two ways to go about that. One is to find like a new old stock part, and the other is to find a parts unit and take that part out of some other device and put it in here. Okay. The problem with number one is I have checked all the usual suspects and I cannot find one of these. Now, I did search on like the NSN number. Okay, that's like a, for military replacement parts or something, and it does show up there. But one website I saw said you have to request a quote on those, and they probably won't sell to me anyway. But one website did say that the average, recent selling prices for these was like $1,000. So that's not going to fly either. Okay, so the other option is to kludge it up and, well, replace just what's needed or, whatever. Does that make sense? What I've done, I've gone and drawn the schematic of that part, and I actually laid it out exactly as it's laid out on the thing itself, according to the schematics in the HP service manual. HP service manual. There we go. And then make a printed circuit board. That's one possibility. And I've actually gone through the exercise of designing the circuit board and trying to make sure it'll fit, and that's what you see here. This is an actual size printout of the printed circuit board, and it would use surface mount transistors. I've got through-hole resistors for the voltage divider so that those could be hand selected, because again the ratio is what's critical there. You have a 1K, a 9K, and a 90K, but what you're really looking at is divide by 10 or divide by 100 for these, and then there's a divide by 1, if you will. There are two other resistors, which, where are they on here? They'd be right here. And those didn't look as critical, so I made them surface mount parts. There's a 10K and a 1 ohm resistor. Okay, so that's a possibility. Is just make a replacement part, PC board, and plug it in. And now this leads me to the question of why did HP in the first place design a custom part for for this thing? And I think that has to do with just the available space. The form factor was fixed. The size of the board. They already have one piggyback board. But I think it was a available space issue where they said, to fit this all in, we're going to have to squeeze it down a little. And so we can take these 10 transistors and these 5 resistors and get and put them on a custom part. And I don't know if these were made in-house or You know, it may be that say Caddock made the resistor part, and they had them put extra pads, and then they went to Fairchild. I'm making this up. Okay, this is pure speculation. Went to Fairchild and bought the the dice for the FETs and finished it by hand at HP. Who knows? Or maybe they made it all in-house. Maybe they had that capability. But the final possibility, before I go that route and actually order those, I want to make sure or have some reasonable, sense that it's going to work. And since we have two bad transistors, what I've done is I've put, these are J112 JFETs. I had 3 left. They are J112s. I had 3 left, and so here's 2 of them. That's the gate, and that's the gate. Source and drain are interchangeable. So, and what I did here, see, every other pin of this socket header is actually connected to a trace on the PC board. But I left the pins or the sockets in, cut the tails off, the sort of in between ones here. So that one, and that one, I've soldered a jumper down in there, which there's no way I'm going to be able to show you that. Maybe, I don't think so. And so those are all connected together. So this is pin, let's see, 12, 13. Okay, so that's 13 and that's 13 also. And if you recall from the original schematic, pin 13 was common on these, all 4 of the JFETs that are on the input side. So that's source or drain, it doesn't matter. And pin 13, there's the gate, and there's the other pin. Okay. So what we do now is plug this thing back in on top of it and see if it approximately works. All right, and here we go. It's plugged in there with those transistors underneath. And so I don't know what's going to happen here. We'll plug it in. We're on volts, manual setting. Okay, I'll turn it on and see what happens. What will we expect? We expect to see 0 volts. Oh, let me put the shorting bar in place here. Okay. So we should see 0 volts. Or something close to it. Well, that's not working. Okay. Well, we've got another problem. Presumably. Notice, that's weird. So we appear to have another problem. And what is that problem? I do not know. Oh, this is supposed to have 1 volt in for this test, but it's showing overload. It's showing overload. And there's the logic test. And I forget what that's supposed to look like. It's supposed to take 4 seconds or something now, as I recall. Well, here we are. We're on the 1. Whoa. Oh, we're on the test range. That's right. Yeah. Nothing. Volts just goes straight to current. Let's see current. You know, it's like it almost wants to do it. It almost wants to say 0, and then, no. Oh, this is on, oh, I'm sorry, this is on ohms. This is on ohms. It's 4-wire only, so, well, I wanted to switch to current. Okay, same deal. Same deal. All right, so we're back to needing to do some more troubleshooting here. Let's check those test points. What do you think? Test point 1, 0 volts. That is correct. Test point 2, 0 volts. Well, that's correct as well. So what seems to be the problem here? There could be more. There could be more bad transistors on this chip, or those, you know, those divider resistors could be bad as well, for all we know. And I ought to be able to test those because I know what pins they connect to, assuming that the schematic is accurate. So if I remove this, it's unplugged, yes. I'm going to remove it carefully. Okay. And let's see. So like the 1K goes from pin, let's see, 1, 2, 3, 4, 5, 6, 7, pin 8 to pin 20. And switch to ohms. 1, 2, 3, 4, 5, 6, 7, 8. And 20. What? Wait. Okay. Okay. Where was I? 10, 9, 8, and 20. Everything's broken. There we go. So that's 1K, more or less. That's not. Got a, I think it's a sticky relay in that. Okay. So the 1K looks okay. Let's see about the, let's see. I can't measure the 9K directly, but it looks like the 99, I can go from pin 3 to pin 20. And that's not 99K. Now, there are JFETs in there. Boy, oh boy. It's hard to say, because if those are on, and I think, you know, with N-channel JFETs, when they're just sitting there, they're kind of on. Hang on, let's test that. Here's one of the J112s. And let's see, that's the... I better check my pinouts. I wrote them down, you see, on the... That's the gate over there. So this is source and drain. Okay? So we'll just measure the resistance from source to drain of this thing sitting by itself. Nothing. 0. Yeah. Okay. Confirmed. Please proceed. So we have a path from here through here to there, which could be messing us up. I'm measuring. See? Can you see? Yeah. Measuring from here to here, but those two JFETs kind of make a path, so I'm not sure that was a valid test. All right. Well, we'll proceed from here, I guess. Okay, so this is weird. What I've got here is I've taken this thing out, that thing, and I've jumpered pin 1 to pin 3, which is in the multiplier circuit, in the sort of the second half of things. That's the feedback loop for this buffer amplifier. You can see that. And then I'm injecting a signal here, basically at TP1, so that when this gets switched on, that will pass through. It's always going to be a gain of 1, and the auto 0 is going to be essentially disabled. Okay. So I turn it on and I see randomness, and it's way up here, and that's really weird. But now, if I put the voltmeter probe on test point 2, now it's reading about 0. Okay, and yeah, I have 100 millivolts in right now. That's got to be there. So that's putting what, like 10 megohms to ground, essentially, through that meter. Okay. All right. Wait a minute. Let's back up here. This comes in at test point 1. Okay. There. That is connected to test point 1. Now, input is set to 0. Turn it on. Well, that looks like 0. Okay. I go 0.1, 0.2, 0.3. There you go. Okay. Now it's out here. It's out here. So if I touch this to test point 2, does that stabilize? I said test point 2. Does that stabilize it? Okay. Where's my clip lead? I'm going to put that on test point 2. Okay? Now, I have 0.3 volts coming in. That is reading 0.3 volts, even with this off. With it on, it's bouncing between 0.3. Okay, and there you go. 3, 4, 5, 6, 7. And I can step, and you'll see the decimal point moves. But if I give it 1 volt in, 0.1, 0.2, 0.3, all the way up to 1.0. So that says a lot of stuff is working. If I go to 2 volts in, then it goes to overload, which it should. And now it's kind of confused. Okay, so yeah, you can see. Okay, that's with 1 volt in, 0 volts in, 0.1, 0.2, 0.3. This is good because the decimal point's in the right place. So basically, it works, but I think there's additional bad transistors in here. that mess up the gain settings. Because notice it's not. Oh well, wait. Well, what's the deal with this thing as well? That goes wacky. I'm not sure. I assume that has something to do with this as well. So at this point, I am inclined to go ahead and make up some PC boards, or make a replacement PC board and try that. Because it seems like, well, most of the problem is within here. It's more than just those two transistors, and I'm not going to be able to proceed any further without having some sort of replacement for this. So I think the PC board is the way to go. So we'll work on that, and that's going to delay the next video. I have other stuff I need to work on anyway. So, yeah, this will be continued somewhere down the line.